Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 61. In today's lesson, we are going to talk about IDisposable and the C# dispose pattern. So we've actually used dispose in the past, and I must have meant to mention it, but I must not have, because I was looking through my previous episodes here and got to noticing that this wasn't actually there, and I thought we did this earlier, but apparently not. So we'll talk about it today. So disposing is what it sounds like. It's a way to end your classes, end your it's a way to end something. So here we have if we remember, this was reading from a text file. So here I'm writing a text file and I'm just using regular write. And then I'm just reading it here to mess around with it and then deleting it at the end. So dispose is a way to make sure that something happens. So it happens when the program or when the class is being removed from your program. So here we start, and I've got these for examples. You really would only want to do dispose now. It used to be close. I believe close and dispose actually do the same thing, so I would expect they're doing the same thing. So notice here I've got these, and I'm doing them in the order they came in. I actually don't know if that's required. I actually did test that. But this will work, and we'll write it out to the console file contents. So that's all we're writing to the text file. And I was going to set a breakpoint here and just show it, but this is creating the file, and then I remove it at the end. So dispose is the C# method for saying, okay, this class needs to do something when it finishes, and dispose is what it does. So let's see. I was wondering if it showed me what they actually take. It does not. I'm going to click that and see if it pulls anything up. I don't think it did. Yeah, it's just showing me usage of it. That's not what I want. Okay, so what's happening behind the scenes here is that this is using, I don't think I can step, oh, I can. But it doesn't say. Stream. There. So stream implements what's called IDisposable. So stream implements it, and then whatever the next layer up from there, file stream implements it. So IDisposable is what you tell C# to say, okay, this class needs to have a dispose method, and both of these end up going down to stream eventually, and they both have a dispose method. So the way we did it in the previously was you can do this as well. You can do using, and it does the exact same thing. So the using is actually better than doing dispose yourself, because there's a problem with dispose. So if you have this, if something in the middle threw an exception, like say this read to the end throws one of these exceptions out of memory, or IO exception or something, you never actually hit the disposes. But the correct pattern here is something like this. I'm trying to think how I want to do this. Let's do it like this. Let's do try. We'll do everything else in here. So the correct pattern is something maybe a little more like this. And this may not be exactly right, but there we go. So that's a little more correct, and we'd want to do it here as well. Sort of hoping it would give me a refactoring for the actual pattern. There we go. So there's just the pattern, and that one will be a little safer. If read to end here actually threw an exception, or this, we would still hit this dispose and hit this dispose. We wouldn't actually delete the file though, so technically we should wrap one more as well. Something like this, so just wrap all of this in one more. That gets very hard to read very quickly, as you can see here. It's a lot of indentations, and there's a better way. So C# introduced the using. Let's do it like this. Using. Let's do it. This. That is the equivalent there. So that C# knows, and you'll see it's giving us our factoring. We're going to do that in a second. It knows since it's IDisposable that using means I'll dispose on that, and that lets us get rid of that one and this one. Then we can get this, this. There we go. That's much more readable. There's a problem though. I don't have a disposing here, so there's nothing I can actually do on this one. And we'll fix that in a minute. What we can do here though is something like this. So we have the option here of use simple using statement. And so this is perfectly fine. This one will work, and it does exactly what we think. So this ends up becoming, or getting translated to do basically this. There's a newer format for that, a using statement instead of a using block. That. So now this using is, it's available from this point on in this scope. So whatever the most recent scope is. So inside this other using. And doing so like that, it still does the same thing. So once it falls out to the end here, a dispose happens. Going to see. Yeah, I don't have it open there. But yeah. So that's the same thing, and then this one here. So once these fall out of this try block, they're now being disposed properly, and that's a whole lot more readable. And this is what I would expect you'll usually see, because in my opinion, this is more readable. Once in a while, though, you might need to occasionally control the scope a little better, and that's when you would use the other one still. So that's using and dispose. Let's implement dispose, and that's how we're going to deal with this. So let's say instead of test, let's say this is I don't know, we'll call it file worker, something like that, and it's going to implement IDisposable. So we'll implement interface as a dispose method. Right now it doesn't do a whole lot. Right now it just throws a not implemented exception. So let's do some logic here. So we'll take what do we want? So here when we create it, let's do that. Let's do a constructor, and we'll take a string path and string content. No, we're not doing anything major here, and this is a bad thing to do in a constructor. Probably you would want to actually do a method, but write all text, path, content. So I'd probably rather do this in a separate method, but we're going to use this here. So a constructor takes place at the beginning of a method or at the class. So when you create the class, constructor happens. When you dispose of the class is when the class ends. So here we can do file.delete. We'll do path. So let's save off path. String path. We'll do it like that. There we go. So now we can do this exact same thing. So we will do file worker. We'll pass it in temp test and file contents. Let's do this thing. String path equals temp test. That way I don't have to type this out as many more times. The nice thing about this format is now these go away. So now there's a problem though. A problem here. Unnecessary assignment. So it's doing all the work here. So let's fix that. Let's do public void write string contents file.write all text, and then we'll remove that. Do it a little better. We'll do it like that. We'll remove that because we don't need it. And there we go. A little nicer. Now we can use this as well. So we can just use we can use a primary constructor. Then we don't need this either. Oh, wait a minute. There. Apparently the refactoring tools on Visual Studio and Rider don't hardly work the same. Rider, that first one would have worked. So there. Now it's a primary constructor and it's using path here. So that works. There's a problem though. We'll just move to that. There. So now we create it and we write it. We don't actually dispose of it though. So let's confirm what happens there. If I run this, file contents, everything seemed to work. Nothing happened, right? Well, fortunately, C# is the garbage collected language, but let's put a breakpoint. There, we hit a breakpoint. Right. It may actually be smarter than I thought it was. Oh, I just need to refresh. Wait a minute. There we go. Okay, so here's the directory there where we're putting it in. Let me see if I can make it bigger. I don't think. There. Temp test though. That didn't hardly do what I wanted to do, but there's the file, and that's the file name we gave it here. It created it. If I open it with something, you could see it. There, file contents. But it's still there, so watch what happens here. So if we continue, file's still there. So we didn't call dispose, so that's why that happened. And I'm stopping the breakpoint because it didn't create, but I was in the wrong directory. So what we would do now, file worker.dispose. Now it makes sure to finish that when we do it. So now I need to come in here, delete this. Now if we rerun it, unhandled exception. Process is being used by another process. Okay, so think what's happening there is all this is still being used. So we might end up having to use the using anyway. So let's fix that. For that, let's put this in the try block like before. So we'll say try all this stuff. Now this should scope. Oops. Now this should scope the inner stuff here as a inside the. It should scope all the inner stuff there inside the try block. Now let's see if it works. Now we don't have the file. So let's run it again. Now let's see what happens. So now it popped up really quickly, but then went away. So that one works. Since we implement IDisposable, though, we can do the other pattern. So we can just use a using. I think it'll be smart enough to figure out the correct order here. So let's try it. Now, I don't expect any exception to be thrown. Exception. I also didn't actually see the file. Wait a minute. Let's do 9 here. And let's hit a breakpoint here. Okay. Files here. So now, if we continue, the file will disappear. And it does. So by doing that, we were able to say, okay, when you're disposing, actually get rid of it. I was thinking, let's see, let's do this. Let's add do this. Disposing or deleting file. Let's put a message here. Finished running program. Let's do this too. Well, I made it the primary constructor, so now I can't do this. So let's make it back to a regular constructor. CW finished construction. W finished writing to file. Okay, so now we got a little bit of setup around. So let's just see what the order is here. So this, we finished construction, we wrote the files, we got the content, finished running, and we deleted the program. That seems good. So let's see. I was thinking I wanted to put some more comments here and show the ordering. Let's do. Need to make that back to try finally though. I'm gonna do this the easy way. I'm sure there's a way in Visual Studio to do it. I just don't know what the refactor is for it. Let me go here in Rider. So Rider gives you the option here. It's just another IDE for visual or for it. If I do control dot here, I can just do try finally. I can do try finally. Now we can write some here. So what I'd want to do here, let's move this down here. Let's go back to Visual Studio, sorry. Visual Studio, CW, disposing of file stream, disposing of stream reader. So we're going to see here that creating stream reader, we're going to see that this actually, the ordering makes sense from this, and from this structure we're going to see that the ordering actually makes sense. So creating file stream, so it makes sense and follows the order we expect, and that's the good thing with it. So here we finished construction, we wrote to a file, we created a stream reader, or file stream, a stream reader, we read the contents, we disposed, we finished. At the very end, which is where we have the scope, here 8, it's scoped to the main method. So at the very end of the main method, it finished. If we wanted to add our own scope, we could actually do that. So if we did this before we've closed the program, now what we're going to see is this should be the very last execution. Let's see. Here, finished. There we deleted the temp file. So that's showing using scope based. So it's using these blocks here as scope. I guess I haven't mentioned that before, but you need to create your own scope for some reason, which I've not usually found a good reason to, but if you need to for some reason, that's how you do it. You just add these, and that's technically valid. Let's undo. We'll undo all that. So let's do this. I'm going back to Writer just a second. I'm going to control dot on the file worker one and do convert using. Yes. There we go. Now we will get that same behavior as well. Now when we run this, we still expect console.writeLine to be the last thing. Yep, there it is. So there we go. So that's a little playing around with Dispose. So if you need something rescoped, you can use these. You can use the other brackets. That's actually bad. That's actually on both. Let me move those. Let's just run it again just to confirm that it still finishes last after the deletion. So same thing. That was a mistake. That was both of them. But pretty good. So what I would recommend, however, instead of these, so we can tell that this is going to work because of that. So we can tell the pattern's correct. But that's just showing some of the importance of scope. I would recommend in general, unless you have a good reason not to, get rid of our console write lines. I would generally recommend using a simple using rather than this. I noticed that, or I don't get the option here to, I get the option there, let's see. Okay, so a Rider actually doesn't give me the option to do the disposings there. So good. Okay, so we're back in Sanity. I'll type in a using there. Here, Visual Studio doesn't give me anything. Rider knows that it'll automatically be disposed, so this isn't necessary. So it wants me to disable it, so I don't want to do that. Instead, let's do, let's just fix it. So we will move this out, move that, move that. And there we go. We're back. So I would argue that this one's the best by far because we don't have any native scope. If you needed to do something with the scope, however, you would want to do it in another order. But I'd argue that this is by far more readable and close enough to the same thing for our purposes. So that's the IDisposable pattern, and C# uses that. I mentioned there's a fs.close. That should do the exact same thing as dispose, I think. You would want to check the documentation. I don't have documentation open, but you'd want to check the documentation. So let me go ahead and pull it up. So we'll look up C# file stream. Maybe. There we go. File stream. So let's see. Let's look up a method close. Yeah, here we go. So closes the current stream and releases any resources such as sockets and file handles associated with the current stream. Instead of calling this method, ensure that the stream is properly disposed. So there's the important bit. So this is the way they used to do it, and now they recommend using dispose. I'm pretty sure close was around before dispose, so they hadn't when they made it, they hadn't thought of doing the up here. And derived classes do not override the close method. Instead, put all the stream cleanup logic in the dispose boolean method, implementing a dispose method. The reason for having that and close is at the time when they originally did the streams, dispose wasn't thought of yet. So I think if you look here, yeah, it closes all the way back to 1.1. If we look at dispose on this, let's see. I believe that's 1.12. Interesting. I would have thought that would have been a little further back. So yeah, I don't actually see anything here. We're not going to mention that. Basically, though, close should do the same thing as dispose, if I understand it right. So the dispose is the correct pattern and the more modern, but when they first did the streams, they hadn't come up with the dispose pattern yet, so it didn't match. I think that's, from my understanding, why, but you should use dispose now instead of close. And I would argue you should use using unless you need to scope for some reason, but I could see someone trying to make an argument that the other one's more expressive, and maybe. But yeah, so that's dispose. The other one it mentioned there was a finalizer. I've never had a reason to use a finalizer. They look something like this, so remove empty finalizer. So finalizer, we could do file.delete path. Now let's not call dispose here. Let's see what happens. All right, we'll leave that there. Let's add a finalizer call. Let's see what this does. So let's run this. So let's remove the using statement here. So right now, the current state, the text file does not exist. Does not exist. So let's see what happens now. So finished construction, finished writing, file contents. But it stuck around. If we call dispose, let's do that. Now, let me delete the file. I deleted the file. Now, if we run it, now let's see what happens. For deleting file, finalizer still didn't show up, but the file did appear and disappear. Good. Let's do one more thing. Let's see. So let's do file worker dot. No. Let's do it the other way. Let's do it unsafe actually. Let's try this. There's the error. Okay. Yeah, and that left us our file. Okay. So the idea of a finalizer is that they're supposed to be called when the class goes out of scope. I was going to see if I could get it to call, but I actually don't know how to do that. So the recommendation from C# goes to use dispose rather than try to use a finalizer. As we can see there, I wasn't actually able to get it to call here. Let's go back to one that works. And that's the general recommendation I've seen, is that they recommend instead of doing something like this, to do this instead. And this one should be guaranteed. This one's not guaranteed. Here we could do this. Implement. No. Is that in right, or I just read that? The warning? There. So here, CA 1816, change file worker dispose to call GC suppress finalize object. This will prevent unnecessary finalization of the object. It has been once it has been disposed and fallen out of scope. So that's cool. Now let's see if it can. So that's apparently not going to work. So yeah, that was great. So let's see. So it was GC dot there. I guess we want to do that at the end. So that prevents this one from even being called. So GC here stands for garbage collector, and you generally don't want to be doing stuff here if you can help it. Let's see if we can get, if that'll get it there. I actually haven't used that one, but no. Okay. So yeah, I don't know actually how to get the finalizer to call, but the general recommendation is not to rely on it because they're not guaranteed to be called. So that's the actual dispose pattern, and this is what you'll usually see. And a lot of times you'll even see it like this instead. You'll have disposing, and you'll have a protected void dispose or boolean disposing. And then here, if I'm going to say not disposing, then I would do all this stuff. I've seen this pattern as well. And you would just call dispose true here. Maybe this actually goes here instead. But yeah, when you would actually implement this for something you would need, or you should go see what the recommendations are for all the different pieces, and see what the recommendation are, and actually apply them. This is used in the situation where you have inheritance in place. So you inherit this, and then each one that inherits from this can do something a little different in of the dispose here, but they all get the original public one. I guess this would be virtual. Like that. The protected virtual, yeah, that seems more like it. So that lets you be able to override this, so you would be able to change the dispose here to do, if you had more stuff like the class you inherit from maybe has something it needs to dispose of as well, you would use it you would use this pattern to inherit from it and then do some other disposal. Something like this, I guess. Let's just make the example. Class test, it inherits from file worker. There, we'll add that. Use primary. Let's do generate overrides. Yeah, we'll just do the one we want. Boolean. Here, so we'll call base dispose. And then we would, if we had something else we needed to dispose of, we could do it here. So CW dispose of anything we need. So then if we call that up here, let's just do that as call it test. Test, and now everything else stays the same because all these methods are I don't have these as abstract, so we can just use them directly. Now we should see this line of text. So let's see. Dispose of anything we need. And over here, it deleted the file. Good. So there we go. So there's dispose and a little playing around with it, a little showing what's possible. So I've run into this one quite a bit. So from my personal experience, it's pretty common. That's what I didn't think to actually mention it, but that's how you would clean up stuff in C#. So if you do get more into unit testing, you would see more of it there because XUnit and TUnit, it's a newer one. They both use dispose. They use a similar pattern that you use the creator to start or do anything before, or the constructor to do anything before a test, and the dispose to do anything after a test. And it can be useful sometimes. So this is the pattern though. So IDisposable, the dispose method. Maybe you just do everything here. Maybe that's fine. Maybe if there's inheritance in the mix, you do it a little more explicitly and do this instead, and then you call the base dispose and do anything else you want to do there. But in general, that's the pattern, and you should generally, if something needs disposed, you should dispose of it, because this will technically work without this, and we've seen that eventually it should get disposed of anyway because C#'s garbage collected, and once you no longer need something, it should close it. But at that point, you're waiting on letting it tell you when it's ready to dispose of it rather than when you're done with it. And say you have something that only allows so many connections, that's when you could run into it. So you need to dispose of something so you can do a new connection, and this one hasn't got rid of it because you didn't get rid of it. And then you get the fun part of how do I close it without letting .NET finish with it. I ran into that as well before, so this is just a quick example using dispose, but there's any other ways to use it. So I think that'll do it. We're a little short, but I think this was a good side topic, and we'll decide next time for what the next topic will be. I may try to see if there's any other side topics I want to gather and do one more of them, but we'll see. Otherwise, my thought is leaning back in toward a couple more algorithms, or data structures, not algorithms, data structures, before we move into the next bigger topic. But I'll think about it and decide. So we'll call it there. So thanks for watching. This has been Programming with Shadow, episode 61, I think. So thanks for watching, and have a wonderful rest of your day.